Okay, let's pull together what we've done in this section. Let me just run quickly through how we deal with zip width, how we define zip width, and how we can use it to redefine zip. Okay, let's take a look at this file here, and what we want to do is define zip width. Now, zip width takes a function and it takes two lists. Now, if either of those lists is empty, the answer is empty. So we have that case, we have this case, and I'm going to actually put an underscore under the F because as the F isn't used here, we'll suppress that warning. So if we have the second argument is empty, the third argument is arbitrary, we again get, a, what have I done here? We again get an empty list. So what do we do in the final case? What's the answer in the final case where we have an element, a function f, we have x cons x's, so we know both the lists are non-empty, so we have y, and we also have y cons y's. What is the answer? Well, the answer is it's f applied to x, y, because we're applying f to pairwise, applying f pairwise along the list, and then we cons that on the front of zip width. F x's, y's. And of course that whole thing is a list, so we better enclose it in square brackets and end the definition with a full stop. And there we have our definition of zip width, and let's finally export it, and that should allow us to compile the file, and then let's give it a go. Zip width of, what should we do? Should we add some things together? So let's say fun x comma y, and let's say max x comma y. What this should do is take pairwise maximum of the elements and it will do that along 1, 3, 2, 4 and comma, and let's say 0, 5, 4, 4, 4, 3. Let's see what we get from that. Oh, of course, I've done the usual thing. I've not put the function in there. And what we see here is we get the answer 1, because the maximum of 1 and 0 is 1, maximum of 3 and 5 is 5, maximum of 2 and 4 is 4, 4 and 3 is 4. So what we do there is, you can see that now I could also have just put in max 2 and just said fun here. Now I should say Erlang. When you have a function where you don't need to use the module it belongs to, you actually do when you call a function like this. So max implicitly belongs to the Erlang module, and what I've done there is say that explicitly. So there we've got the zip width. Now how can we define zip using zip width? What do we do there? Well, let's try zip width. What do we need to do? We need to take the two elements, x and y, and what we need to do is turn them into the pair. So what we need to do is, let's find our function here. What we want to do is turn the two arguments x and y into a pair. And that's what I do there. Whoops. Sorry about that. That was meant to happen. Let's get rid of that backslash, and if we do a return, you can see that that's giving us precisely the definition of zip. It's taking those corresponding two elements and sticking them in a pair. So once we've got the zip width, it's relatively easy to get zip. Now also, in fact, we can go the other way around, and that was an exercise for you to try out. So I leave it to you to complete that. So what we've seen in this section is functional patterns running along a list, zipping things and so on, are often an instance of a general function where the generality is provided by a function, an argument which is itself a function, and that embodies what's specific about a particular definition. And so we can reuse these higher order functions, these functions that take functions as arguments, again and again in defining our programs. And that's particularly the case with lists. And I'd encourage you to take a look at the lists module in Erlang, which is full of these higher order functions. Okay, so that's it for section 3.1. What we'll do in section 3.2 is look at a larger example, and we'll say some more about higher order functions in there. Particularly, we'll say something about how we build functions that return functions as results. So that's what we'll look at in the next section. But if you didn't complete the zip exercise, why not have another go at it now? Or if not, time to move on to the next section. Okay, thanks very much.